Yesterday we did the last problem that we did to get together yesterday was a property problem from Friday where we had to apply the property to help us to solve the equation. And this one's going to be very, very similar to that. We're going to have the ln of x plus 1 minus the ln of x equals the ln of 4. Okay. And I know Friday it's been a few days, but we talked yesterday about one that had a plus sign here in between. This one has a minus sign in between. And when we have a minus sign in between, what are we going to do with the two expressions? We're going to divide them. Okay? So we're going to combine the left-hand side together into one ln, a single log. And because it's minus between them, we're going to divide. Okay? And here's the important thing to note as well. Some people want to write it as the ln of x plus 1 over the ln of x. There's only one ln in the problem. The ln of x plus 1 divided by x. Okay, so we're combining those together. We divide the two expressions, leave a log in front, equals the ln of 4. We don't have to do anything with the right-hand side. Now, when we get to this point, because we have a log on both sides, we have a log here and we have a log here. I could rewrite an expression here, like if I said the ln of x equals the ln of 3, then what would x have to be in order for these two equations to be the same, or two sides to be the same? We just have to put 3 in here, right? X would have to be 3. So we're going to do essentially the same thing down here. This expression and this expression have to be the same. Because there's an ln in front of both of those, I can essentially drop the ln off to get this. Because whatever's in this spot has to be 4 to make these two equal. Okay, now we've talked about a lot of different algebra things, and when we look at this one, is it okay to just knock the x's off? No. Okay. Why not? Perfect. Because it's tied in by the addition sign. If it was 1x over x, then yeah, I can knock it off. But the addition sign ties those together. So in order to knock this out, I would have to have an x plus 1 on bottom. We talked about that a lot when we had rational functions. And we had like the vertical asymptotes and the holes and all of that. I have to have a common factor on top and bottom. X plus 1 and x are two completely different factors. So our goal here is to solve for x. To get x by itself here, let's get rid of the fraction. So we're going to multiply by x. So we're left with x plus 1 on the left. We got 4x on the right. And now we're going to solve for x. Now this is a real basic equation to solve. And then we divide by 3, and we get x equals 1/3. So obviously we got some logs and some exponentials, but then a lot of it's just some algebra skills too, and being able to solve and remember some of our algebra scenarios and how to solve some of those things out. Okay, I'm going to give you another one here that's very similar to the one we just did. This one's going to be a little bit different as far as what the answer is and what we get. setting it up essentially the same way we did the last one. We always have to pay attention to the sign that's in between the two logs. When we have two different logs, whether it's ln or log, whatever log we have, then typically on problems like this, we want to combine them together to make a single log, okay? We don't really want two logs on one side. I got to make it a simpler equation to solve. We're trying to be able to get x by itself. So we're going to combine these two logs together on the left-hand side. Once again, because it's minus, and that's why it's very similar to the one we just did, always put the first expression on top, the second expression on bottom. And it gives us that. Hey, and this is where it's very similar to the last one as well. The last one, though, we had a number over here, so that made it a little bit easier. Here we have an x. But because we have a log on both sides and ln on both sides, whatever is in this spot has to be equal to x, because we're taking the log of the same thing, right? So these two expressions must be the same. So once again, I can really just drop that ln off. Because there's an ln on both sides, this expression has to equal this expression, and so I could rewrite it like this. But this one's going to be a little bit harder to solve. What would we do first here? What do you guys think? You could take a 2 out. You could factor it. We don't necessarily have to here, though. And it wouldn't help us a whole lot to do that, but you could. Yeah, let's get rid of our fraction, right? Let's get rid of we want to get that fraction out of the way. And so I'm going to multiply by x plus 5 on both sides. When I do that over here, that gets rid of my fraction. Okay, it gets x plus 5 off the bottom. And it just leaves me 4x plus 6. Hey, and then what are we going to do over here? Yeah, we got to distribute. Okay, and remember the goal here is to solve. What kind of equation do we now have? Quadratic. Yep, we got an x squared. And what's the first step when solving a quadratic or any equation? Set it equal to 0. So I'm going to move the 4x over. I'm going to move the 6 over. So I got 0 over here. Okay, and you got a couple of options here. Okay, a couple of options would be you could factor it, you could graph it, you could do a lot of different things. Okay, it really doesn't matter to me which way you go from here. And because it's a quadratic equation, we talked about, I mean, heck, you could do the quadratic formula if you want to, but that's probably not going to be our choice here. Graphing it would be what a lot of people would do. Okay, and there's nothing wrong with that. This one factors fairly easy. Multiplies to get -6 and adds to get 1 would be +3 and -2. But those are my factors, so my zeros would be -3 and +2 if I set those both equal to 0. If you graphed this, these would be the two places it would cross the x-axis. Okay? And like I said, if you want to graph it, go for it, and you see that's where it crosses the x-axis. But here's what we got to remember. Yesterday, one of the problems that we did, we had two solutions. We had one where we got like a plus or minus 3, right? And we said those were our two answers. Well, what we found out is one of those didn't work. And the easiest way to do this one is, let's say that I plug -3 in right here. Can I take the ln of -3? No. And if you're not sure, put it in the calculator. But remember what we said. We can never take the log of a negative number. So I can have a negative answer as long as when I plug it back in, it's going to work. But in this case, when we're taking the ln of x and x is -3, that is not going to work. okay? So immediately I can knock out the negative 3. Negative 3 is not going to work here, okay? Let's try 2. Make sure that 2 works. 4 times 2 is 8, plus 6 is 14. 2 plus 5 is 7, and then this one is 2. So the ln of 14 minus the ln of 7, because we have a minus sign in here, we can take 14 divided by 7, which is 2, and so both. That one does work. So my answer here simply would be we'll cross that one out, and we'll just say x equals 2. Bless you. So when I get 2 answers, that doesn't necessarily mean both of those are going to work, okay? Just because it's negative doesn't necessarily mean it's not going to work, okay? Negative numbers could work, but when I plug it in, I can't take the log of a negative number. And so that's what you got to kind of keep in mind, okay? And there could be a situation where maybe even a positive number wouldn't work as well. So those are all different ones to talk about. On this last one. Yesterday we talked about using the calculator. If you wanted to, you could move this over, set it equal to 0, and you could put this whole thing into your calculator. So let's get your calculators out and let's practice that. And I'm just showing you a different way. I showed you how to solve this one algebraically. If we set it equal to 0, and I put that whole thing into my y equals, okay? It's kind of a weird equation to put into the y equals, I get it. But I want to show you something here, and I think this should work if we do this. And that's what we got solving it algebraically. Now, solving it algebraically was a lot of work to get there, so that's why I'm showing you, like, graphically, on some of these, we could solve it graphically. We could find where it crosses the x-axis and save ourselves a lot of work, okay? But in some cases, we may have to solve some of these algebraically, especially if our calculator is not going to get us where we need to be. Okay, so I just wanted to show you those two. This last thing I'm going to talk about here, and these are on page 370. This was from 5.4. We didn't do anything like this on our notes the other day, and I didn't put any of these on your homework. But this is just applying the log rules. And so because we have a little bit of time today, I thought today would be a good day to talk about this. So if you have your book out and you want to open up to page 370, you can. If not, I'll just write it up here as well. I'm looking at number 64. Okay, in the directions, they give me log base A of 2 is about 0.431, sorry. Log base A of 7 is about 1.209. And log base A of 11 is 1.490. Okay, so number 64 says log of 14 base A. Okay, and like I said, you're gonna have a problem like this on your test next week. That's why I'm going through this with you. I want to find the value of this. I cannot put this into my calculator because we don't know what the base is, right? And we're not solving for A. We're trying to figure out what log base A of 14 is. So we have to use these three things to somehow help us to evaluate this. So we have 2, we have 7, and we have 11. how can I use 2, 7, or 11 to get 14? Seven times 2, right? So I could rewrite this as 2 times 7. 2 times 7 is 14, okay? So we got to figure out which ones of these we're going to use. Those are the only ones I can use, and I got to use those numbers to get to 14, right? Now here's where the log rule comes in play. If we have a multiplication sign, this is the product rule. When I separate them, what am I going to do? Add them, yeah. So we're going to go log base A of 2 plus log base A of 7. Okay, do we know log 2 base A? Yeah, it is 0.431. We also know log base A of 7 is 1.209. That's given to me. So then all we got to do is add those two decimals, and that is our answer. Okay, 1.64, I think is what we get. Okay. So it's a little bit different way of applying the log rules, right? But you got to use the 3 that you're given to get to that expression. And there's a couple of different ones like that. The second one, let's look at like number 70. This one gives me 3 different values. Log base B of 2 is about 0.356. Log base B of 3 is about 0.565. And log base B of 5 0.827. And number 70 says log base B of 5 over 3. So this one's even easier, right? Because it already tells us the operation that's happening here. We don't have to figure out the operation on our own. When I separate it, what are we going to put in between the two logs? Minus sign. So we're going to do log base B of 5 minus log base B of 3. Okay. You cannot put these in the calculator. You have to use the expression they give you because we don't know what that base is. We don't know what B is, right? So these are not calculator problems. Sometimes they are, so this one is not. You have to use the values that they give us. This would be 0.827 minus 0.565. And then that's the part you can put into your calculator. Okay, and you're not going to necessarily use all 3. Like in this one, I didn't use the log 2 base B. Okay, you might use all 3, and if you did all 4 of those problems, you would eventually use all 3 because that's why there's 3 of them there. But to do that one specific one, you may not use all 3. Okay. So just a little bit different variation of using the log rules and using them to help us evaluate. Okay, assignment. I'll go ahead and give you the assignment. I'm going to give you some time today to work on this assignment, and if you didn't get as well. And then when we get to 31, we're going by 5. So just add 5. 36, 41, 46, so on. Okay. extremely important that you do those problems, guys, because as we talked about yesterday and then again today, there's a lot of different types of log equations, log expressions that, I mean, they're all different. And this, I tried to pick out ones where you just had a wide variety of different types of equations to solve. So you've been exposed to a little bit different set of problems. Work on that. If you need some help, I'll come around and help you out and give you a little bit extra time to work on that. Once again, we switched the schedule up. I didn't do one like this yesterday. And as we go into the last section, we're going to see a lot of problems like this on 5-6. And so I want to show you one like this. Our goal is to get t by itself. Okay? And yesterday we said anytime we had a variable in the exponent, we want to log a frog to solve it. Okay? And that's still going to be the case here, but before I log a frog to solve it, what am I going to do first? Here's what I would kind of compare it to that, in that I have 100 in front of the exponential part of the equation. So I got to get rid of that 100 that sits out in front, first of all, before I do the log a frog to solve it part. And that will give us that. Hey, now what log do we want to use here? ln. Yep. Anytime we see an e, ln is probably going to be our go-to. You could use log, but ln is going to be our go-to because it's going to be a little bit easier. So I'm going to do the ln of both sides. I'm going to jump the exponent over in front. And as we said yesterday, anytime I have the ln of e, this is why we choose to use ln as opposed to log. That way I don't have to do like the log of e or whatever. Ln of e is really what? 1, right? So we can essentially just knock that out because this is really just 1. And then multiplying by 1 doesn't change anything. And then to get t by itself, we're going to divide by 0.08. Hey, and we talked about this yesterday as well. Be really careful about putting this into your calculator. We're going to do the ln of 25. And like I said, on most of your calculators, it puts an automatic parenthesis there when it opens it up. So you got to close it off after the 25 and then divide by the 0.08. Okay, the last thing that I want to go over with you, and I was going to mention, let's say I have an absolute value equation. And on an absolute value equation, we said we can't distribute the 2 throughout the absolute value, right? It's different than parentheses. So what would I have to do in that case to get the absolute value by itself? We saw something like that early in the semester. Divide by 2. Let's get rid of this 2 because we're taking 2 times this whole thing, right? So to get rid of the 2, I would divide by 2. And this one is very similar.